Hello, my name is Dwayne Dortch, and I'd like to welcome you back to another edition of our video series on EdgeWorkers. Our topic today is the EdgeWorker Code Profiler, which is a great tool for helping to understand performance issues associated with your EdgeWorkers execution. But first, let's start with the refresher of the limits of EdgeWorkers related to CPU and memory. My colleague, AJ Johnson, created a blog post in January of 2023 with some updated limits. Let's take a look at that on the Akamai website. As we go down here to some graphic results, note the decrease in resource-based errors on the day that the rollout of the new limits took place. You can see a drastic drop in the error rate based on the increased limits. This is a 10x reduction compared to historical averages. Now let's dive into the world of performance profiling. From an EdgeWorkers perspective, there are three limits that you want to keep in mind. They are CPU time, wall time, and memory utilization. My colleague Tim Barik created this illustration to help explain these limitations. Let's say we have an EdgeWorker that does several actions, in this case A, B, and C. It then fires a request and waits for a response to come back. When the response comes back, it does two additional things, X and Y. There are two timeouts here that we need to be aware of. The first is the CPU time, which is the time when our EdgeWorker is actually executing code and consuming CPU cycles. So it could be reading or modifying or validating a cookie or adding headers or doing some regex, whatever in the JavaScript code that will execute CPU cycles. Next is waiting time. So once the request is sent, we wait for the response to come back. That could be a couple hundred milliseconds up to a couple seconds. And waiting time is not part of the CPU time. And then when the response comes back, we may do some additional EdgeWorker actions that require CPU, some modification to the response. Again, more CPU time. And then we have wall time, which is the total time of the overall EdgeWorker execution, including the CPU time and the waiting time. With these definitions in mind, let's review the updated limits in the blog post that we just reviewed. For all of the on-type event handlers, that would be on-client request, on-client response, on-origin request, on-origin response. Those event handlers have increases in all four of the categories. CPU increase has gone from 10 to 20 milliseconds, wall time from 4 to 5.5 seconds, memory from 1.5 megabytes to 2.5 megabytes, and the number of sub-requests have increased from 1 to 4. This is a really huge improvement for EdgeWorker capability. It opens up a whole nother world of possible use cases, being able to execute multiple sub-requests from a single event handler. Likewise, for the response provider event, the CPU has also doubled from 100 to 200 milliseconds, wall time from 4 to 8 seconds, memory from 1.5 to 4 megabytes, and the number of sub-requests has remained the same there at 50. So some really important expansion in the resource limits for EdgeWorkers. Also note that we've implemented something called dynamic bursting. Dynamic bursting provides some additional headroom for these limitations. So if you do happen to go slightly over the reported limits, you won't get an error. We'll be able to handle that with this new dynamic bursting functionality. Well, let's get back to the code profiler. Prior to this new profiler, our option for debugging was using advanced debug headers. There's another video in this series about how to use advanced debug headers. But here we see an example of the output from using these advanced debug headers. Note the output of the wall time and CPU time, where we give the overall value but don't break down exactly where in the EdgeWorker the CPU and wall time is used. So enter the code profiler, which tells you exactly where resources are used within your EdgeWorker. The profiler provides CPU profiling, so it breaks down the CPU cycles per function in your EdgeWorker code. And the profile was also recently updated to include memory profiling, which shows how much memory each part of your code consumes. There's great documentation on the EdgeWorker profiler in our tech docs. There's a section under developer tools called Code Profiler. That'll give you full detailed documentation of how this tool works. A few things to note about the Code Profiler. The profiler only works on the staging network. So you can't use it on the production network, but only in staging. You won't get an error if you try to use it in production. You just won't get any output. Also, you need to have the advanced debug headers turned on in order for the profiler to work. Again, we've got another video on how to set up the advanced debug headers, but just note that you have to have the advanced debug headers turned on in order to take advantage of the detail from the Code Profiler. And as mentioned, it profiles CPU, memory, and wall time. Okay, let's look at the Code Profiler in action. There are 3 ways to use the profiler. You can use the CLI, you can use an IDE, particularly Visual Studio Code, or the IntelliJ IDE plugin, and you can use Chrome. In this example, we'll focus on Visual Studio Code. Well, here's an EdgeWorker that I have running on my personal website, dwaynedorch.com. It does some simple personalization by displaying the city and country that you're visiting from. Looking at the EdgeWorker code, you can see that I'm using the on-client request event as well as the response provider event. Once you've installed the toolkit for Visual Studio Code, and there's a link to that in the description below as well as in the tech docs, you'll see a new tab in the Visual Studio Code panel called Akamai EdgeWorkers Code Profiler. Here it is here. And this is where we set up the use of the profiler. Here we can add the URL that we want to profile. We can select an event handler. In my case, I'll select the response provider event handler that I'm using in my EdgeWorker. You'll also choose whether you want to do CPU or memory profiling. Here we'll do CPU. You have the option to force a cold start of the EdgeWorker, which runs the EdgeWorker initialization code first. This is startup code that runs outside of the EdgeWorker and is part of the total wall time. So if you're trying to get additional insights into your wall time consumption, forcing the cold start can be very helpful. You also have the option to add request headers. As mentioned, you will need to add the advanced debug header. And again, there's another video linked below for how to set that up, but you will need to add the EdgeWorker trace header for the advanced debugging. So let's go ahead and run the CPU profiler on our response provider. Notice that you get all the functions that have been called. There's a column for total time as well as self time. And you can order by any of these by clicking on the column header. You can click on the flame icon in the top right corner to view EdgeWorker execution details in a flame graph. Flame graphs illustrate the stack trace and the amount of time spent in each stack frame. So here we're showing all the functions that were called. The wider the box, the more time spent in that function. You can click on a box to zoom in or use your mouse controls to zoom in and out. Note the depth of the function calls. Again, we can zoom in and out, we can move around with our mouse. We can search for a particular function. If we type in, say, transform in the filter box above, you can search for where a particular function is executed. And if you hover over a function, note the aggregate time and self time. Aggregate time is the total time that function spent, including all subfunctions, and the self time is the time for just that function. Okay, I mentioned that you can also run the profiler in other ways. One of those ways is using Chrome DevTools. The profiler generates an output file that can be read by many tools, including Chrome. There are a few ways to generate this output file, one of which is to use the VS Code interface that we've been using. You can also generate it through the CLI. Let's look at VS Code. The CLI method is fully documented in the tech docs as well with some good examples. So let's run the profiler again, but this time let's enter a file path and file name in the options. And when we execute, the profiler generates an output file. Then if we go to Chrome, open up More Tools, JavaScript Profiler, click on Profile, we'll be able to load this file that the profiler has created for us. And you can see here in Chrome, provides a nice interface for viewing the profile results. Okay, well, let's summarize what we've talked about so far. First, the updated limits that we've seen are great. We've seen a 10x reduction in number of errors since implementing them. Also, we noted that the new dynamic bursting is enabled for everyone and provides some additional headroom so that if you do exceed those published limits, you're less likely to get an error. The code profiler allows you to debug your EdgeWorker and JavaScript code for CPU and memory. You can run that from the CLI, from Visual Studio Code, as we've seen in this example, as well as other tools that support standard debug file types like Chrome. Stay tuned for news on upcoming enhancements to the code profiler. Thanks again for joining us today, and we'll see you again in a future video.